welcome to Mastering Innovation Together with Alan Kent and Chris Koomey of Thorben Consulting. And Alan, we're talking about AI and coding. And back 30 years ago, when the internet was just getting available to most people, you were starting with a blank piece of paper and had to build everything from scratch. And then there were more sophisticated tools that came along where you basically could have things pre-done for you. And now with AI, it's taking that to a whole new level. So how do you see this evolving over time with the AI impacting coding?
Yeah, so how you mentioned of going from the punch card days to early coding, we started with very limited processing power. Your memory was very restrictive on how much memory you had, so you had to be very, very efficient. You had to account for every bit occurring. The general trend in programming has been abstracting away the lower level, getting to a higher level logic. You have going from punch card days of actual flipping arithmetic bits up to like 8086 assembly, which is still very low level, involved in the swapping things in and out of memory, then to your higher level programming languages like C++, a general use programming language like Python, which abstract away a lot of the lower level stuff and let you focus more on the logical flow of the program. In a way, a lot of the AI has the potential to be yet another abstraction away from that. If you take a look at OpenAI's CODEX, AWS has a new service called Code Whisperer that's in beta. Both of those can take natural language and translate into code. So now instead of having to write the high level function that's specific to the programming language that you're using in syntax to say, hey, I need to do XYZ, now you're getting to a point where you could pretty much write a comment block that says, this is a function that does XYZ, and then these models can generate that function for you that does it. So it allows a farther degree of abstraction away from the actual code. There's still definitely going to be use cases of needing to go in and optimize that code, definitely when you're running on lower power devices, IoT devices, stuff like that. But for quickly prototyping things, this has the potential to really speed up that development curve.
Yeah, that's so interesting, is that it's just a logical step. People talk about AI and they worry about it replacing people, but the reality is we've always been optimizing and moving forward. So where do you see this going over the next few years?
That's a hard one. So it's always hard to kind of predict what the bleeding edge of technology is going to lead to. You go back to the early days of the internet and ask somebody to predict what's happening. Very few people would probably predict that we'd all be walking around with a brick in our pockets that had access to all this information on demand. So it's really hard to predict where it goes. I think we're going to see the models continue to improve. I think we're going to see more conversations on the ethics of AI and how do we make the models ethically sound, sampling good pre-training data. I know one of the AIs that I have particular kind of focus on outside of work is Tesla's full self-driving stack. Trying to accomplish the complicated process of driving a street that it's never seen, and that's something where the rules of the road aren't even consistent from location to location, and there's so many tasks that require human judgment of when it is safe to actually ignore those rules in the favor of safety or to get from point A to point B. I think that model is going to continue to progress. Will it get to 100%? That last 1% is always going to be a really, really hard hurdle to overcome. That's you've solved 99% of all the easiest scenarios, which means the 1% of the hardest scenarios are remaining.
And that's
So
other people get involved. And that's, I think if every car was on the same logic, it probably would work great. But I think the real challenge is having humans involved that aren't on.
definitely, yeah. Anything that exists in a petri dish that you can control all of the elements for, that's very easy to automate from without even necessarily needing AI involved, because you can account for all the variables. But the reality is that there's almost no real world task that doesn't have a degree of randomness, a degree of influence by humans, and humans are just chaotic by nature. So you need the holy grail that a lot of companies are chasing after is that general use AI. So instead of, historically, a lot of the AI models have been trained for a very specific objective. Of, you can kind of look at even the full self-driving stack by Tesla. It's trained to recognize, okay, this is what a stop sign looks like, this is what a curb looks like. It's been tuned into that specific task. They also have their Optimus bot that they're working on, that's trying to be a little bit more general use, where it doesn't have a particular task pre-programmed into it. It more has a understanding of the world around it, and you can teach it to do a generic task. So that's kind of the holy grail that all of the companies are chasing, is that general use AI, that one model to be able to apply to any task, and for it to be able to outperform the average human on a majority of those tasks. And I think one evolution that we might see there is a kind of general use AI that ends up selecting a specialized use AI to accomplish a task. So the general use AI understands what you're asking of it and says, oh, well, I might not be able to solve that, but I have a friend that can. So I think that that's kind of the next kind of natural stepping stone. Again, the end kind of dream goal that everybody's chasing is that one AI to solve it all.
And I think that's probably the fool's gold. That's probably not going to happen.
Mm-hmm.
Whereas just think about all the software that we have that's very specific to a particular task. So I think evolving, they'll probably not one general, but a lot of very specific use cases that then can get cobbled together.
Yeah, to compare it to a lot of the cloud native microservices. So kind of a microservice architecture where you have producers and consumers. You have one model that talks to another model that talks to another model. And in a way, you can kind of equate that to a human brain, in that we learn how to accomplish a certain task. We learn different skill sets, and it's the interaction of those skill sets that makes us capable of tackling something brand new, or tackling a more complex task that involves multiple domains.
No, that's great insight, Alan. So I appreciate you mastering innovation together with us today, and we'll talk to you soon. Thank you for mastering innovation together today with Thorben Consulting. This is Chris Koomey. We'd love to hear from you. If you enjoy the show, if you have any comments, questions, or just want to learn more about what we do. Thanks for joining us.